Before I had the mind to take two topics together because EtherChannel is not long. Maybe within 1 hour we'll be done. But later on, I changed my mind because sometimes some people don't like two topics back to back. And for people that cannot really flow well on the platform, as far as multiple topics are concerned, in one class, I just thought about it. I said, I will not take I will not take two topics together today. So I'll take one topic today, which is just 1 hour plus or less. Then on Wednesday, we're going to meet again. I will be available for that class. So what will have taken me out of the class has been shifted to Thursday, and we don't have class on Thursday. So that's a good, that's plus for us in the class. So we're going to be talking about the EtherChannel. I believe some people must have listened to the video on EtherChannel because I sent some recordings ahead. That is to make this work easier for everybody. But even if you have not listened to it, we are still going to do it together. But it's good to always listen to the videos ahead, because that will make the work a lot easier. And after this class, we're going to have some labs. I will send the labs. And I want to appeal to you people that the labs that I'm sending after every class, all those labs are very important. I am not insisting that you submit them to me because I believe we are all adults. We are mature. We know that this is what we need to do. You need to go through those labs, because if you don't go through those labs, when it comes to final exam skill in CCNA2, you are going to have problem. And it's not just about the skill final exam. If you want to write certification, you're still going to have problem. So the best way for you to master technology is by doing it in IT. This is the secret. We say lab. It's by labbing. So any topic I teach you, I send you 1, 2, 3 labs. Make sure you do all those labs. They are important. So I can't say more than that. So let's start this one. So EtherChannel, what is EtherChannel all about? Last class we talked about spanning tree protocol, and we did a lot of stuff on spanning tree. Yes, Mr. Davis, please go ahead.
Okay, Davis, good
Oh,
evening, sir.
forgive me, madam. I'm so sorry.
Yeah, used to men.
Man, yes.
No,
And the name sounds like a male name, Davis.
that's my surname.
Oh, that's why now your surname comes first. All right, you have the floor, ma'am.
Yes. Yes, sir. We can't see the screen, sir.
Ah, you were not interested. And
Yes,
I share the screen now. Let me reshare. I share the screen since. Please tell me if you can see it now. What about now?
we can see it now. Yes.
Oh, thank you. Thank you.
Okay.
I did not know you were not seeing it. I just assumed. I will have just started talking and continue teaching. So I believe we can all see the screen now. So can I proceed? I should okay, thank you. Thank you, ma'am. Okay, so EtherChannel, we're going to talk about what's the objective. The title is EtherChannel, you can see. What's the module objective? Is to troubleshoot EtherChannel on switch link. That's not the only objective, but that's one of the objectives. So we're going to talk about EtherChannel operation, which basically describe EtherChannel technology. We are going to learn how to configure EtherChannel. We are going to verify and troubleshoot EtherChannel. So these are the 3 things we are going to learn. And in less than 1 hour, we are done. This is not like spanning tree that will took forever. Talking. EtherChannel operation. EtherChannel, another word or another phrase to refer to EtherChannel is link aggregation. link aggregation. So if you hear us say EtherChannel, that is Cisco's terminology. But the open source, the rest of the world called this link aggregation. And what is this technology all about? There are scenarios in which more bandwidth or redundancy between devices is needed than what can be provided by a single link. Multiple links can be connected between devices to increase bandwidth. However, spanning tree protocol, which is enabled at layer 2 devices like Cisco switches by default, will block redundant links to prevent switching loop. So what are we trying to say? What are they trying to tell us here? Sometimes you have two switches. Let's call this one switch A, and let's call this one switch B. Ideally, we have one connection. But in our last class, we put two connections. Why did we put two connections? We want to use one as primary link, the second one as secondary link. If one fails, the other one will pick up. But they are trying to tell us something here now. Sometimes you need more bandwidth between this connection, these two switches. Why would you be in need of more bandwidth? Maybe the traffic you have here, that's computers now. Computers you have on this other side that are talking from switch A to switch B to switch A, vice versa. There is bottleneck on the connection between the two switches. When I say bottleneck, you don't have enough speed. Maybe the connection between these two switches is just 100 meg. And since spanning tree will block one of the link, we're using only 100 meg to communicate, or let me say the traffic is traveling over 100 meg. So what can we do if we are beginning to have bottleneck? We can add another connection so that we can now have theoretically 200 meg on this link. The spanning tree is going to block one of the links. We know that that is going to happen. But the reason why we want to connect two cables now is not because we are looking for redundancy now. That's what we did with spanning tree. The reason why we are connecting another cable is because we want to have more bandwidth. So how can we make that happen? What we are going to do is we are going to bind these two cables together, or these two connections. We will bind the two of them together. And by binding the two cables together, spanning tree no longer sees these two connections as different connections. So it sees it as one connection, and therefore it will not block any link. And the technology to bind these two links together, you can bind 2, you can bind 4, you can bind 6, you can bind 8. I think it's in maximum is 8. So the technology that enables us to do this, to achieve this, is called link aggregation or EtherChannel. So we have more bandwidth between the two switches. So if one connection is 100 meg, theoretically, the two connections should give you 200 meg. When I say theoretically, you are not going to get 200 meg complete, but at least you will increase your bandwidth. So what have we done? With this technology, we are going to full spanning tree. Instead of spanning tree blocking a particular link, once we bundle those links together, it sees them as one, so it will not block anything. And we're going to see it at work today. A link aggregation technology is needed that allows redundant link between devices that will not be blocked by spanning tree. And that technology is known as EtherChannel. So whether we say EtherChannel or we're saying link aggregation, we're saying the same thing. Is Ali in the house? I am expecting a question from you people, and I won't want to talk about it now. I will just continue teaching. Then let me see if somebody is going to ask me that question. Ali is not around. Mr. Reggie is around. Those are the people that used to ask me questions frequently. So I will see if you are going to ask that question. EtherChannel is a link aggregation technology that groups multiple physical Ethernet links together into, look at it here, one single logical link. Look at something here. It is also used to provide fault tolerance. What do I mean by that? Even if I bundle two cables together, or I bundle four links together, 1, 2, 3, 4. If I bundle these 4 links together, spanning tree is not going to block any of the links. All of them will be working simultaneously, and there will be no problem because they are seen as one. But what happens if one of the cables that I bundle together goes bad? The rest are still working. If another one goes bad, the rest are still working. So in a sense, we have been able to achieve fault tolerance. We load sharing. Somebody is saying, can't see my screen. Mrs. Davis, you can see my screen, right? Mr. Oroji, can you see my screen?
You can see your screen.
Okay, Mr. Patrick, are you using phone? Maybe you should log out and log in.
Screen, sir.
Okay,
sir.
Yes, sir.
So what are the things we achieve when we do EtherChannel? We achieve fault tolerance. We achieve load sharing. Why? Because some of the packets are going through one of the cables. Some other are going through in another cables. Another one set of packets are going through another cable. We achieve increased bandwidth. We have more speed between the two switches. And we also achieve redundancy between switches. Redundancy is if one fails, another one is still there. It's almost the same thing as fault tolerance. And this can be done between switches, routers, and servers. So this technology is not only applicable between switches, it's also applicable between routers and servers also. The EtherChannel technology makes it possible to combine the number of physical links between the switches to increase the overall speed of switch-to-switch communication. That is the main reason why we do EtherChannel. Every other thing is just by the way. The main reason why we do EtherChannel is because we want to have more bandwidth. And look at a good example here. Look at a good example here. There are 2 links here. These 2 links will bundle together. It's going to become one logical link. On the other side, the 2 links will bundle together. It's going to become one logical link. And we're also going to do our own also. The EtherChannel technology was originally developed by Cisco. Cisco owns this technology actually before the rest of the world caught up with Cisco, and then they decided to do their own. As a LAN switch-to-switch technique of grouping, take note, grouping several fast Ethernet or gigabit Ethernet port into one logical channel. I'm going somewhere now. When an EtherChannel is configured, the resulting virtual interface is called a port channel. So the moment we configure EtherChannel, we have a logical interface that is called port channel. The physical interfaces are bundled together into a port channel interface. Let's do it before we come back to the story. You know, I like to, in between, tell stories, do labs. Tell stories, do labs. Tell stories, do labs. So let's go. So I'm going to bring out 2 switches. And we're going to link them together, just like we did in our last class. We're going to use 2 cables. So we'll know what is going to happen. One link is going to be active at a time. the other link will be blocked. And what if I don't want that? So I want to use one stone to kill two birds, meaning I want to achieve redundancy, and I also want to, instead of me just doing leaving spanning tree to block one link, why don't I just activate EtherChannel? So I will still have my redundancy in place, and then I get more bandwidth. So we can see right now, spanning tree has finished its job. One of the connection is blocked, and we've seen this. But what if this is not what I want to do? I want the two links to be used. I want the two links to be bundled together. This is fast Ethernet connection. It simply means it's 100 Mbps, 100 megabit per second. That is the speed of fast Ethernet. So what will I do? Very simple. I'll go to my switch. I'll say interface. I have to enter the two ports at the same time. And if you are dealing with 4 ports, you enter them at the same time. Range, fast Ethernet, 0/1, spacebar, hyphen rather, spacebar, then 2. I've used this command before when we did VLAN. So I'll hit enter. Look at, I am in multiple ports at the same time right now. What do I want to do here? I want to bundle these two ports together. I want to bundle it together. Now, best practice. People will tell you, go and shut down the other side of the link so you don't have some inconsistency when you are done with this configuration on one side. So let me go to the other side and do that. Let me go to the other side, enter the two ports simultaneously, and shut them down. So just say shut down. When we're done with the other side, we'll come back here. Let's name this switch or switch B so we'll know the difference between the two. So I've shut down the other side. Let's name this guy switch A. So let me go back to the range. Now, I don't need to shut down my switch A part. I've shut down the switch B. I want to bundle all the ports here together. When I am done with this configuration on switch A, I will also go to switch B and do similar configuration. You watch now. Well, I'm going to go back to the story. I just want to show you something. The command is, what's that command again? I think it's channel group. Yeah, channel group. Channel group, that's a command now. Channel group, now look at the range of the number, because you have to pick a group number, and that is the number that will define the logical interface that will be created. So I can say channel group 1 mode. Let me put question mark. Channel group 1 mode. Look at all the options we have here. Channel group 1 mode. If I say active, what am I doing? I am activating LACP. What is LACP? Link Aggregation Control Protocol. That is the open source, the one on other vendors switches. If I say auto, I'm activating Cisco's own. Cisco's own is PAgP. If I say desirable, I'm activating Cisco's own. If I say on, I am not making reference to any whether open source or what do you call it, or Cisco's own. I just want to activate EtherChannel, and that's what I want to do now before I go back to the story. So I'll just go here and say channel group 1 mode on. This same command that I'll issued here, I'll go to the other side and issue it. You are going to see that the two connections, the two links, that's the two connections that we have between the two switches, they will bond, they will form EtherChannel, and spanning tree will see them as one. So let me copy this command before I go to the other side. I'll hit enter here. Look at what it said, creating a port channel interface, port channel 1. That is the logical port that has been created for me. I'll go on this side. I'll go to the other side and also do the same thing. Enter that those ports, put this command, say channel group 1 mode on. Don't forget we'll shut down this place. I will now bring it back. You can say no shutdown. Just this one command. You will see what will happen now. Spanning tree will no longer block any of my links. The two links will be working simultaneously. And so how will they work simultaneously? Because we have bundled the two cables together. How do we confirm that we've bundled the two cables together? We're going to see from our command output. So we're waiting. Don't forget I'm on the default spanning tree. I didn't go to wrap page. Have you people seen what's happening here? All the links are up. Spanning tree didn't block anything. Why? Because spanning tree is seeing these two cables as one. Let's confirm that. If I go to show port, is it show port channel? No. Show. Sorry, I always forget some of these commandos. Show what now? I will have to check it from the, I think it's show channel group. I can't remember. I have to go to what do you call this? The PowerPoint to check down. But there's one command I want to say. Let's do our show spanning tree. Show spanning tree. Show spanning tree. What are you guys saying in this place? In different ports. I mean, it's saying these two ports as one port. When we did our spanning tree in the last class, you see fast Ethernet 1, fast Ethernet 2, it's alternate port, it's forwarding, it's this, it's that one. Spanning tree is not seeing that now. It's seeing these two, this thing as one. That is the power of bonding. That is the power of EtherChannel. So there's one command I'm trying to, I think it's show EtherChannel something. Let me try it now. Show EtherChannel. Okay, yeah. Show EtherChannel summary. That's the command I'm looking for. Show EtherChannel summary. Show EtherChannel summary. You see, the group we created is group 1. And the interface that was created, that is the logical interface, is called port channel 1. You can see it here. What does this SU mean? We come to these flags here. The big S, that's a capital S, means this is a layer 2 connection. The big U means it's in use. That means it's working. Under protocol, you see nothing is showing. We're going to talk about the protocol now. The protocols defined is pointing to whether it's a Cisco's own or open source. This one, we didn't point to any protocol. We just say on. How many ports were bundled together in this place? We have 2 ports bundled together. Fast Ethernet 0/1 and fast Ethernet 0/2. And what does this P mean? The P simply means the ports are in port channel. Anytime you see D in front of the port, it means the ports are down. Anytime you see I, it means the ports are standing. They did not bond. They did not, you didn't bond them together. You need to be aware of this. This is EtherChannel for you. Just one command and we are done. Look at the command again. We enter into the ring and say channel group 1, you can say 2, you can say 3, mode on. This is one of the ways to configure EtherChannel. There are other ways. We're going to talk about those ones briefly. And then we come back and configure those ones too. Any question on this before I proceed? Are we together? Am I communicating? Okay, thank
sir.
you. 777 or thumbs up. Good. All right, thanks. So let's talk about the advantage of EtherChannel. Then we're going to come to some other story, and then we'll go back to configuration. Okay, Ali, I think you are not in the class when I spoke about shutting down the port. It's good to go to one side and shut down the port on one side because of because you could run into, there could be loop on your network because of inconsistency in the configuration. One side is yet to be configured, one side has been configured as EtherChannel. So best practice, they tell you shut down one side of the port, then go configure the other side, and then come back configure this side, and then you can bring it up. So you don't have switching loop. Okay. EtherChannel technology has many advantages, including the following. Number one, most configuration tasks can be done on EtherChannel interface instead of each individual port, ensuring configuration consistency throughout the link. What is the meaning of that? By the time we bundle these two ports together, it created one logical port for us called port channel 1. From now on, anything I want to do that affects those two ports, I don't need to go to those two ports one after the other. I can just go to this port channel 1 and apply the command. If I say go into interface port channel 1 and say shut down, those interfaces will be shut down. Any command I issued here, it's applicable to those two physical ports that makes this logical ports. EtherChannel relies on existing switch ports. There is no need to upgrade the link to a faster and more expensive connection to have more bandwidth. Let me tell you this. EtherChannel is supposed to be a temporary fix for you. If you realize that in between your two switches, you need more bandwidth, maybe here you have 1 gig connection. The best thing is to just upgrade your switches, to go and get the switches that can probably give you 10 gig connection. That is supposed to be the best. But sometimes you may not be able to lay hands on these new devices. So you have to make do with what you have. So it's supposed to be a temporary solution, not a permanent solution, but it will still work for you. But if you have money, you just go and upgrade those devices straight away. Load balancing takes place between the links that are part of the same EtherChannel. I've explained that. They use multiple links. EtherChannel creates an aggregation that is seen as one logical link. We saw that from the output of our show spanning tree. When several EtherChannel bundle exists between two switches, take note of this. STP may block one of the bundles to prevent switching loop. What are we talking about here? What if I have something like this? I have 4 connections. I bundle this together separately. I bundle the other 2 together separately. Spanning tree is going to see them as 2 different cables now. This is one link as far as spanning tree is concerned. This is another link as far as spanning tree is concerned. So he has to block one of the links. He cannot leave the 2 of them simultaneously. He cannot leave the 2 of them simultaneously. It has to block one of the links. But if I bundle all these 4 together, spanning tree will see all of them as one port. But if I bundle 2 out of 4, if I bundle 2 out of 4, spanning tree will, or let me see, if I bundle 2 separate, spanning tree will see them as 2 separate connections and block one of the links and open the other one. Sorry, a call is trying to come. Let me log out my WhatsApp on this laptop. Sorry, please. Okay, sorry about that. So now When STP blocks one of the redundant links, it blocks the entire ether channel. So if I bundle two links together separately and another two links separately, spanning tree will block the whole links bundled together. This blocks all the ports belong to that ether channel link. When there is only one ether channel link, all physical links in the ether channel are active. Why? Because spanning tree sees only one logical link. I just demonstrated that to you guys now. EtherChannel provides redundancy because the overall link itself has one logical connection. Additionally, the loss of one physical link within the channel does not create a change in the topology. If we lose one cable out of the 3 or out of the 4, nothing spoiled. If we lose 2, there's no problem. If we lose 3, there's no problem. Things are still working as it's supposed to be. But anytime you want to configure EtherChannel, there are restrictions you need to be aware of, or implementation restriction, do's and don'ts you need to be aware of. EtherChannel has certain implementation restrictions, including the following. Number 1, interfaces cannot be mixed. Interfaces cannot be mixed. You can't mix, you can't bundle fast Ethernet with gigabit Ethernet. It will not work. They must have the same speed. Take note of that, please. Currently, each EtherChannel can consist of 8 compatibly configured Ethernet ports. You can only merge or bundle 8 ports together. EtherChannel provides full duplex bandwidth up to 800 Mbps. That is for fast EtherChannel. Why? When one of the links, each of the links will give you 100 Mbps. By the time you have 8, you are talking about 800 Mbps, and that is theoretically. And you can do this between switch and switch, switch and router, and switch and server, or between servers also. But on a Catalyst 2960 layer 2 switch, it supports only 6 EtherChannel. You can only bundle cables together. The individual EtherChannel group member port configuration must be consistent on both devices. What does that mean? Anything I am doing on switch A on this port here, I must do them on the other port here. And that is why once I'm done with the bonding, I go to the logical port to be doing whatever I want to do. If one side is strong, the other side must be strong. If one side is full duplex, the other side must be full duplex. If one side is half duplex, the other side must, whatever feature you have on this side, you must have on the other side. If this side is layer 2, the other side must be layer 2 port. If this side is layer 3, the other side must be layer 3. Once you have something not matching, something not working, it's not going to, they will not form EtherChannel. Yes, Mr. Samuel.
Okay, so does it mean when you are bundling switches and routers together, the switch has to be a layer 3 switch? Because if you bundle a layer 2 switch with a router, then it means one port or one end of the link will be a layer 2 port. Why
So
the
if
other
you want to bundle with a router, definitely this side has to be a layer 3 port. So meaning you are using a layer 3 switch. I've never thought about it. I just got the answers. You were asking me the question now.
Okay, sir.
You know, a layer 3 switch, by default, all the ports are layer 2 ports. You are the one to now activate layer 3 functionality on the ports you want to use as layer 3. So one side can be layer 2 connection, the other side can be layer 3 connection on a multi-layer switch. Is that clear, sir? Is it clear, sir?
Yes, it's clear now. I understand.
Okay.
Thank you.
And that's a good question. Any other question, please? The implementation is very simple. You just need to know about the restriction. So what we did earlier, we just turned on EtherChannel on both ends. But we can leave our devices to negotiate. We still want to tell them about the negotiation protocol. So let's go ahead and talk about it. Auto negotiation protocols. EtherChannel can be formed through negotiation using one of two protocols. The first one is port aggregation protocol, and the second one is link aggregation protocol. Port aggregation protocol, link aggregation protocol. These protocols allow ports with similar characteristics to form a channel through what? Through dynamic negotiation with adjoining switches. Note, it is possible to configure a static, that is what we did before, or unconditional EtherChannel without PAgP or LACP. PAgP belongs to Cisco. That means it's only on Cisco route devices you can find this. All other devices, open source or other vendors, this is the only one you can configure, or static. So how does PAgP function? PAgP, that is PAgP, is a Cisco proprietary protocol that aids in the automatic creation of EtherChannel links. When an EtherChannel link is configured using a PAgP, watch out, PAgP packets are sent between EtherChannel capable ports to negotiate the forming of EtherChannel. When PAgP identifies matched Ethernet links, it groups the links into an EtherChannel. The EtherChannel is then added to the spanning tree as a single port. When enabled, PAgP also manages the EtherChannel. PAgP packets are set every 30 seconds, and PAgPs check for configuration consistency and manage link addition and failure between switches. It ensures that when an EtherChannel is created, all ports have the same type of configuration. Note, in EtherChannel, it is mandatory that all ports have the same speed. I talked about this before. Duplex settings, if it is half-half, it is full, VLAN information. Any port modification after the creation of the channel also changes other channel ports. So we may want to run PAgP, which belongs to Cisco. Okay, this is what I'm looking for. When we want to run PAgP, we can turn on two different options. One side is called desirable. The other one is auto. I think we did similar things like this in spanning tree, where I talk about trunking, when trunking can form and when trunking cannot form. Same principle applies to, or similar principle applies to PAgP. If I want to configure PAgP, there are two options. I have one side of my link can be desirable, the other side can be auto. If I have auto on one side, auto on the other side, my connection will never form, will never bond. So it means at any point in time, there must be desirable on one side. So I can have desirable on one side, auto on the other side. These things will form, they will bond. Or I can have desirable on one side and desirable on the other side. You see that they are going to form EtherChannel. So anytime I want to configure PAgP, all I need to do is to just pick one of the options, auto or desirable. Please, can you mute yourself? Somebody is distracting us there. Thank you. So anytime I want to configure PAgP, all I need to do is just to set one side to on, PAgP on, or PAgP desirables. That is what I intended to say. One side can be auto, the other side can be desirable. Look at the combination here. If on switch 1, I configure this side as desirable, and on switch 2 desirable, they are going to form EtherChannel. If I configure one side as desirable, the other side as auto, they will form EtherChannel. If I configure one side as auto, the other side as desirable, they will still form EtherChannel. But once both of the switches on both sides, the configuration on both sides are set to auto, EtherChannel is now going to form. And look at the static also. On, EtherChannel will form. But on, with any, whether it is desirable or auto, it's not going to form EtherChannel. You can't combine them together. That is how you set up PAgP. Let's do that and see. So now, I want to bring out one more switch. And have connection. Let's say port 3 and 4. So on this other side, this new connection, I want to configure the Cisco proprietary, which is PAgP. I have linked the two switches together on that side using port 3 and 4. What will I do? I'll go to the switch A now, global configuration mode, interface range, fast channel 0/3, spacebar, -4. I am in these two ports at the same time now. So let me show down these parts. Remember I said show down one part first. Then I can go to the other switch. Fast channel 0/3. So here now, I want to configure the EtherChannel on this side. Let's call this switch to C. Switch C. So let me use that command again. So I will say channel group 2 mode. Let me put question mark. You see, what I want to configure right now is Cisco's own. So I can either say auto or I say desirable. But don't forget the combination. What is going to make our EtherChannel to form? One side must be desirable. I can't have auto. So in this side now, from this side now, I can decide to say auto here. Hit enter. It has created port channel 2 for me. Then I go to the other, back to the other side that I shut down. I can say channel group 2 mode. If I say auto here again, they will never form EtherChannel. So I have to say desirable. Now hit enter. Then I can now activate these ports, all the ports. Then I can come out of display. You will see that the two switches, the connection between these two new switch A and switch C, I believe, will form EtherChannel. Spanning tree is not going to block any of the protocol. I mean, any of the links. It's going to leave the two links up simultaneously because it's seeing the two connections as one logical connection. And then we're going to check what type of EtherChannel technology are we using on that side. Is it the static or the Cisco's own? So let's find out. I'll go to this switch here and say show EtherChannel summary. You can see the first one we saw what happened between port 1 and 2. Look at our second connection here. Group 2 is what we're using. Look at under protocol. Look at what we got here. This other one hub didn't show us any protocol because it's static. We just said channel group 1 mode on. We just run it. But the second one, we are specific. We want the Cisco's own. So we configure auto on one side. We configure desirable on the other side. And if you like, you can do desirable. This is when you want the two devices to form EtherChannel dynamically. But if you know you don't have time for that, just go and on EtherChannel between your devices statically. Any question on this? Thank you. Any other question? If you don't have question, just give me thumbs up or 777. Thank you. Okay, so thank you guys. Let's go to the last one. Remember I said there's also LACP. Look at the combination also. For LACP, of course, we talk about static. If I on this side and put for LACP, you have two options. One can be active, the other one can be passive. It's more or less like when you have auto on PAgP side and then you now have desirable. Just a change of language. They just change their own language. So for LACP, if you have active on one side, active on the other side, EtherChannel will form. Active on one side, passive on the other side, EtherChannel will form. Passive on one side, active on another side, EtherChannel will form. If you still have passive, they were not going to form EtherChannel. And this is the way LACP is configured. It's just a change of terminology. It's the same thing. They do the same thing. So let's go to that one and see. We're going to add another connection now on the last link between the two switches. So let's add another connection here. Let's use port 5 and 6. So now I've connected port 5 and 6, and I want to bundle those links together on that side. I'll go to this switch, port 5 and 6, shut down one side first. Shut down. Then I can go to the other side. And say channel group, let's say 3. Mode, look at my options here. I can say passive. And if I say passive, that means I'm enabling LACP. If I say active, I'm also enabling LACP. Now, look at the word. I think I want to read the statement in front of the active. Enable LACP unconditionally. Active means I am going to go out there to look for somebody to form EtherChannel with. The same thing with your desirable. But look at passive here. Enable LACP only if LACP device is detected. So this side, I can decide to leave this side as passive. Go to the other side and make that side active. Same thing, I say channel, group 3, mode, active. If I make mistake and do passive here, they will never form. Then I'll say no shots. Now let's see if this guy also will form EtherChannel. So we have learned how to configure LACP. We've learned how to configure PAgP, and we've also learned how to configure static EtherChannel. So let's wait for it to form. Don't forget, spanning tree is still doing its job. That's why it's slow now. If we don't want this slow stuff now, we move to rapid spanning tree before we configure our EtherChannel. I like this. The EtherChannel has formed. The spanning tree is doing its job because we have a connection all around. So let me confirm to you that the EtherChannel formed. I'll go to this switch and say show EtherChannel Summary. You see, one of the connection we have PAgP. The second connection we have LACP. This is the new one we just configured now. The spanning tree has blocked this link. Just like what we did in the last class, you cannot have that round connection because you may have loop. So now, as far as spanning tree is concerned, let me explain something to you here. As far as spanning tree is concerned, you cannot have something that will circle all together and it will continue. It must block one of the link. Because spanning tree is seeing this as one connection, one connection, one connection. Even though we bundle things together, it still has to block one of the links. And that will take us back to what we did in the last class. So the fact that you are bundling things does not know. Hello, can you hear me, please?
Yes, sir.
Okay. So you can see that LACP formed. We have port 5 and 6 inside it. But if I issue show spanning tree now, you will see something here. This port 3, this logical port 3, what kind of port is it? It's alternate. And look at the status. It's blocked. That is the job of spanning tree. So for it to open this link now, that means another connection must be done somewhere before it can open this link. And one more command to show you before we go back to our theoretical stuff. Show IP. Is it show IP? Let me check this one first. No, it's not this one. Let me go to show run. I should be able to see. I want to show you that our logical port was created. Yeah. No, it's not from there. It should be from show interfaces, not show IP interface. Okay, I can see it from my show run too. Interface port channel 1 was created. Interface port channel 2 was created. And even if I go to show interface, I should see show interface status. Status is not showing. Okay, yeah, it's showing. Port channel 1 is created. Port channel 2 is created. These are ports that were bundled together. So all these port channel 1 and port channel 2, they are logical ports. They were bundled together from physical ports. And it could be 4 ports, it could be 6 ports, it could be 8 ports. This is what EtherChannel is all about. It's all about creating bundling ports together in order to get more bandwidth. And of course, you still achieve redundancy. Any question on that? So the remaining part of this is just for them to show us what to how to go through the configuration. So we're just going to walk through. I've shown you guys how to do it. I'm just going to go through some of their show commands, and if there are things to point to, I will talk about them, and then we'll wrap up the class for this evening. No question? Can I move on? Okay, good. So don't forget the limitation, or let me say the restriction. The speed and duplex must be the same. The VLAN must match. The range of VLAN must match. Don't forget that one. Look at a good example here. This is 1 gig. This is 1 gig. Full duplex. Full duplex. Please mute yourself. Mute yourself, ma'am. VLAN 10. VLAN 10. Mrs. Davis, can you please mute yourself? Okay. So we've done our own configuration. Look at it here. The command they put. Hello, Mrs. David, can you
No,
please mute
it's
yourself?
network.
So you see, we use this command to bundle the links together. The subsequent command to be issued, I'll just go to the port channel one created. I can decide to say, okay, this is a trunk port. I'll say switch port mode trunk. The VLANs I want to allow, switch port trunk, allow VLAN. Anything I want to do that has to do with these two ports together, I'll go to the port channel to do that. Okay, I think I jumped something. No, I didn't jump anything. So what about troubleshooting of EtherChannel? I always tell people this. Anytime you talk about troubleshooting is all about you knowing the right thing to do or the right thing that should be there. If those things are not there, then you need to find out where you made mistake. Take for instance now, if you are trying to form EtherChannel between these two links and it refuses to form, what can you look for? Are the two sides on auto or they are on passive? Do they have the same VLAN? Are they both trunk links? Do they have the same duplex? And so on and so forth. So these are things you look for. This is what troubleshooting is all about. That's why you need to know the rule of the game. What things are supposed to be there so that you can find out, or you'll be able to spot this is not correct, then you fix the problem. So there are different show commands: show interfaces port channel command, show interfaces summary command, show inter-channel port channel command, and show interface EtherChannel command. Now, how do you get used to this command? The more you work with these commands, the more you get familiar with the command. And the best way for you to get familiar with this command is when you have labs. I don't know if I have troubleshooting lab on EtherChannel. If I have, I'll probably send one to you guys. So you have to walk through. So let's see the output of show EtherChannel summary. I've showed you guys that one before. Look at what we got in this list. Here they have SD. What is the meaning of S? I showed you S means layer 2. D means what? This link is down. Why is the link down? You have to go and verify. This is another command here. Show run 5 begin interface port channel. It can just bring out all the configuration that has to do with port channel. These are some of the commands I've not gotten used to. Any command that has to do with exclude, include, begin, to filter things out. They brought all these things long after we finished Cisco and we've been teaching Cisco. So to now master them for me is a challenge now. So but you guys need to get familiar with this command. You see on another switch too. So you just brought out anything that has to do with port channel. And with this, you can do your troubleshooting because you can verify, okay, switch port trunk allow. This one is trunking. What about the other side? Do they have the same configuration? If they don't, then you can know that that's where you made a mistake. So you can correct your configuration when you've spotted the problem, but you must understand the technology before you can spot the problem. So these are just some of the things you need to be aware of when it comes to troubleshooting. Any question? I think I have 1 or 2 labs on this, and I will send them immediately. So if you have questions, please ask. I told you, EtherChannel is not smart. It's just 1 hour plus. We have not even spent 1 hour. So this is like 59 minutes. So we're going to stop there. I'll send the